Hello everyone. In this video, we will discuss how to calculate the chi-square test with help of the examples. So we have example. We'll try to understand. So here we have two categorical variable. One is vaccination and second is the attack rate. Attack rate is attacked and not attacked. Vaccination, vaccinated and unvaccinated against children against measles. So we try to understand how we'll calculate. Suppose these two categorical variable attacked and not attacked, attack rate is given and vaccination is given for 100 and 100 children were not vaccinated and total sample size was 200. So this is question is given already. We have to prove it. Values of vaccination at 5% level of significance. Is this data is statistically significant or not? Is there any association or not? Vaccine is protective or not? We'll try to find out the solution with help of the chi-square. So here we need to understand how to calculate the value. So first of all, whenever we are going to analyze chi-square test, apply the concept of chi-square test in the data, first of all, we need to develop the statement of null hypothesis. So in that case, null hypothesis would be there is no association between vaccination and attack rate. An alternative hypothesis would be there is an association. So this is null hypothesis and alternative hypothesis. Now we have to calculate, use the chi-square test set at the significance level at 5% or 0.05. So first step in carrying out the test is to calculate the expected count for each cell in contingency table already observed is given in question. So recall that expected count is equal to the row total multiplied by the column total and divided by the table total or marginal value. So we can calculate, this is already given in the questions, 200 samples. This is the observed value. Now expected value we have to calculate. We can calculate the expected value with help of this example. Row total, this is the row total and multiply by column total and divided by total marginal. So then we can find out this value. In place of this, we can find out the expected value. So like this is the expected value column. So we'll get here expected 18, expected 18 and 82 and 82 with help of this formula. So we need to understand row total multiply column total divided marginal total. So degree of freedom we have to find out. Row minus 1, column minus 1 formula we are aware. So here 2 minus 1 and 2 multiply 2 minus 1 would be 1. So degree of freedom here, degree of freedom is 1 with help of the formula. Now we have observed value and expected value. We have to put the formula. In the formula is already aware. Summation observed minus expected whole square divided by expected value. So we can put this is the observed value minus expected value whole square, observed minus corresponding expected, observed minus corresponding expected, observed minus corresponding expected value and divided by total marginal value. This is total marginal value and we can find out the value is 8.67. So this is known as the calculated value. So we have a calculated value. So now calculated value is greater than 3.84 expected value corresponding to P less than 0.05. So here null hypothesis is rejected null hypothesis is rejected. So we can say vaccination is protective. That means though children are vaccinated, so there is less chance of the attack means infected, again infected with the measles. So here one points we need to understand, calculated value and this is the tabulated value. If we are following the traditional method, so like we have manually calculated value, find out this is table value already given 95% confidence level, 5% level of significance with 1 degree of freedom. With 1 degree of freedom, we have find out this value. So here, if calculated value is greater than tabulated value, then we'll reject the null hypothesis. And if we are using the modern method software, and in a software directly we find out the p-value, and if p-value is less than 0.05, then again we can reject the null hypothesis. This is the basic difference. Here calculated greater than tabulated and here p less than 0.05. This is the basic concept of the chi-square test we need to understand. Thank you, everyone.